Hello, my name is Sascha Preibisch, and today I would like to talk about ID token in the context of OpenID Connect. There are a few highlights that I would like to point out before we get started. ID token represent authenticated users. I'd like to say that access token and refresh token represent client applications, and ID token represent the user. This way, it's a good model to distinguish between these tokens, and it's easier to make up your mind which token to use when and where. Tokens are digitally signed and expressed as a JWT, JSON Web Token, which means that any recipient is able to verify that the content is original and is still created or is still shown as created by the issuer. The content is usually a JSON document, which makes it easy to process it. And ID token enables session management, which I will show later on. And they also allow you to do something that I like to call lightweight federation, and I will talk about that also later down in this presentation. So if a client receives a JSON Web Token, an ID token as JWT, the JWT is usually a very long string, which starts at E, followed by a Y, and then goes all the way down to the last character. And you will always see that there are three components, and each of these components are separated from each other by a dot, as in this example. And the first part is called the JWT header, the second part is the payload, and the third part is the signature. And the nice thing is that these first two parts are simply base64 URL encoded, so you can use tools to base64 decode these two, and you will find the JSON content of it. So, this is the header, and it usually contains the KIT, the key ID, and the algorithm that was used to create the signature. And I will explain what this key ID does a little later. The payload, of course, is what you most likely care about, this represents the ID token and the content that is specified by the OpenID Connect spec. The last piece, the signature, of course, is just a hashed value, and there's nothing to decode for that. Now, if we look at the content in more detail, each single one of these values is called a claim, and there are required ones and there are optional ones. OpenID Connect is a very complex specification, and some of these optional claims become required depending on the flow. But as a thumb of rule and as specified, this distinction is in most cases true. So if we look at the required claims, you will always find the issuer who issued this token, and this is a URL. You'll find the audience, and the audience is a single value or a list of values, and each value represents a client ID. So any client whose client ID is found in this list is a valid user of this token. Sorry. The subject represents the user that was part of the authentication/authorization flow when this token was issued. And this will either be a plain string like an email address or a pseudo identifier, pseudonymous identifier, which is not a random number, but it looks like it. And the interesting part is that if you build two different clients that have two different client IDs, but you use the same user, these values will be different. So the idea is that two clients are not able to figure out that they have been used by the same client. Yes. What did I say? So that two clients cannot figure out that they have been used by the same user. Yeah, that's it. Issued at, when was this token issued and when will it expire, the EXP expiration value. These are seconds, those are 10-digit numbers. Then you'll have the auth time, and this is the time when the user was authenticated. In most cases, this time will match the issued at time, or they are very, very close to each other. But it could also be that auth time is much older than issued at, and this is the case where the ID token got renewed, but the user did not need to re-authenticate, because there was still a valid session of this user around. The nonce value, this is required for implicit flows, and this value is the same value that a client included in the token request, and it will just be returned as is. The ACR authentication context class, this will say something about the trustworthiness of the authentication procedure. So let's say you would have a value like level 0. This could mean a user got authenticated via a cookie, or you could have level 4, which would mean that the user was authenticated by a certificate and maybe a one-time password, something that makes this authentication procedure more trustworthy, so that it is you can assume that the user is actually the user who claims who it claims to be. Then we have AMR authentication method, and this is a value which specifies or says something like username password was used or an OTP was used. The specification doesn't define any specific values, so any values would have to be made up for a specific context. And AZP, the authorized party, this could be either a matching value of the audience, or it could happen that there's an authorized party who requested this token, but the audience does not only include the authorized party but also others, or the audience doesn't even include any of the AZP values. This is something that you have to look at into your context to make this a useful field. So, to validate the ID token, if we decode the header again and the payload, as I mentioned, the header includes the key ID, algorithm, and potentially other values, and these claims in the payload. So the first step of validation could simply be checking strings and dates. So after decoding the header, a simple check could be, is the given algorithm one that I accept or that I can handle? And if not, you just not accept this ID token. The issuer, is this issuer a trusted party in your system? This is a very simple check. Was it made for my client? So do you find the client ID in the audience value? And if not, you can just throw away the token and not accept it. How old is it? You could have a rule that says issued at. It cannot be issued with more than 1 minute in the past or 5 minutes in the past. This is how you could leverage this field. And then, of course, the expiration. You want to make sure it hasn't expired yet. So those are really simple validations, just comparing strings. And the second part is the slightly more complicated one, where you would verify the signature. So how it works is you base64 URL encode the header value again. You base64 URL encode the payload, and you combine those two pieces with a dot, and then you use the algorithm that was specified in this header, and you regenerate the signature value. And this signature value you compare to the given signature value. And if those match, you know that this token has not been modified, and you can trust it has been issued by the issuer as the issuer claimed. So if you are now worried that signature validation may be quite a big effort for you, although of course I would always recommend to use a library for that, there's good news. There's a little tip for you. If the ID token was received from the issuer directly via SSL, you may skip the signature. So if your client requested the token of a server at HTTPS domain A, and domain A is also the one who issues this token directly back to your client, you can assume that the issuing party is the one that gave you the token, so to say. So in that case, the spec allows you to skip the signature validation. And this, of course, makes it a whole lot simpler. So, but let's say you have to validate the signature. How it works is you'll grab the issuer value, and after you've checked that you want to trust this issuer, you like example.com https example.com/issuer. If that's the value, and if you have specified that as a valid value in your system, you'll take it and then you'll combine it with .well-known OpenID configuration. This is an unprotected API, and it will return a configuration document, and this document will include the JSON Web Key Set URI. And the next step is to call this URI, which is also an unprotected endpoint, and this will return a JSON document with a list of public keys that are in use right now. So if the server has created the signature with a private key, this key here is the public key, which you can use to validate the signature. And in this example, there's just one key, but it could be a list of keys. And what you'll do is you'll grab the key ID of one of those keys in this list, and you'll find the one that matches the key ID that was provided in the header that you've received. And then you'll take this key, you'll create the signature as explained before, and if the signature matches the given signature, then you'll know that this is the token as issued by the issuer. Now, the ID token usage. One piece of course is, or one use case is, it's received, your client extracts the claims of this ID token and uses them to create a session for the user that is represented through this ID token. Now the claims that I've shown are usually nowadays not the only ones. You'll also find claims that your client would usually have to retrieve through the user info endpoint. So in most cases that is not necessary anymore. You'll find email address, preferred username, email verified, claims like that directly in your ID token. So that's one use, and the other one is if your client wants to request an access token, what it could do is, in this example, let's say it's going to go through an authorization code flow, provide the response type, the client ID, the scope, and the code challenge if Pixie is supported. Now, what your client could do is include the field ID token hint and include the ID token that was issued. And what will happen is the authorization server will receive this ID token, and if it is valid, it will not request the user to authenticate again. And if this parameter is accompanied by prompt equals none, your client is also asking the server to not prompt for anything, neither for authentication nor for providing consent to the request. So if the scope is the one that you've used beforehand, and if this ID token is still valid, your user will have a very smooth experience by not being challenged with any screens. Now the other use case, which is not so common but I would like to mention it, is what I call lightweight federation. So if you look at federation cases, you would usually have domain A and domain B, and they have both set up their system so that users of domain A can access resources in domain B. But a part of this flow is usually that a user's attributes like first name, last name, role, those kinds of attributes are mapped from domain A to domain B. So let's say in domain A you've got a username field which is called user, but in domain B it is called user ID. So there's a mapping from user to user ID which is specified when this SSO single sign-on federation scenario is being created. And that is a federation use case. But in this case, what I mean by lightweight federation is, let's say you've got a website and you've got web content which is freely accessible, but you also have a data API. And you would like to know who is using your data API. You are not concerned about access token to protect access to anything. You just want to know who it is. So you require an authenticated user. One scenario would be you would only accept users that you have authenticated on your web space. And the other use case would be you would allow other domains to manage their users and let these users access your data API as authenticated users. So what you would do is, in your web space, you would specify a list of valid issuers of ID token, and now I would like to say in general case JSON Web Token, which allows you to specify a content of whatever you need, so to say. So you would have a list of valid issuers, and now on this authentication step on your data API, if this website, friend.website.com, would have a button which would take the user to your data API, this request could easily include an ID token or a JSON Web Token in general, and then it's of course issued by this party. And you would go through the validation steps as we just discussed it. So you would check, is this a token or ID token JOT issued by one of these parties? If so, call the OpenID configuration endpoint, call the JSON Web Keyset endpoint, do the validation, and now you know that you have received a request of a user of one of these platforms. One requirement, of course, is that all of these partners or websites also support these specifications from OpenID Connect. So what you could do now is, each time one of these users accesses your data, you could write this event into a logging database with your visitors, and for whatever you have created, whatever your relationship is with one of these parties, you could send an invoice or you could send any kind of feedback to these platforms in order to share the knowledge that these users have used your data API, and you may charge money for that, or you ask for certain feedback or whatever it is. But the main idea is that this signed token enables this use case. Here are a few links. So to OpenID Connect, the starting point, you can find certified implementations here. And I have got these few endpoints here running in the context of my open source project, and you will be able to try out the test client. You can see how a JSON Web Keyset endpoint response looks like, and the same for the OpenID configuration. I hope this was helpful, If you have questions, please leave comments, and please subscribe if you would like to see a future video and be notified as soon as it gets uploaded. Thank you very much.